Hello everyone. This video is going to show you how to predict whether ionic compounds are able to dissolve in water based on the ionic solubility rules found on page 6 of your chemistry reference tables. When you turn to page 6 of your reference tables, the solubility rules are grouped by anion, and so you will find anions that tend to be able to dissolve on the left-hand side and anions that tend not to be able to dissolve on the right-hand side. So for example, all compounds formed with nitrate, all compounds formed with acetate, and all compounds formed with ammonium tend to be able to dissolve in water. On the flip side, compounds formed with hydroxide tend not to be able to dissolve in water, although there are some exceptions on both sides. So let's get into some examples so that we can see how to use these rules. Our first example is calcium chloride, CaCl2. In order to determine whether calcium chloride is able to dissolve in water, we're first going to start by looking for the anion on the list. So we've got chloride. We're going to start on the top left and work our way across. Nitrates, acetates, acid, ammonium, all chlorides. So here we go. We found the rule that addresses chlorides. They are generally able to dissolve in water. There are a few exceptions though, so we need to check our cation and see if our compound is one of those exceptions. Our cation is calcium, and the exceptions are silver, lead, and mercury. So we don't have to worry about any of the exceptions because we have calcium, not silver, lead, or mercury 1. So like most chlorides, calcium chloride is going to be able to dissolve in water. But what if we did have one of the exceptions? So let's look at an example, silver chloride, AgCl. We're again going to start with our anion. We'll find the list that involves chlorides, and then we'll check our exceptions. Our cation is silver, which is listed as an exception. So unlike most chlorides, silver chloride is not going to be able to dissolve in water. Instead of being on the left-hand side with most of the chlorides, silver chloride will be on the right-hand side, unable to dissolve in water. Speaking of the right-hand side, let's look at an example where the anion is on the right-hand side. Calcium carbonate, CaCO3, is addressed by the first bullet on the right-hand side of the solubility rules, where it says that all carbonates and phosphates are unable to dissolve in water. The two exceptions that are listed are ammonium and group 1. It's pretty clear that our cation is not ammonium, so we don't have to worry about that exception. But in order to double check whether our cation is in group 1, we need to get out our periodic table. So we're going to go to the periodic table, we're going to find calcium, and calcium is in group 2, which means that the group 1 exception does not apply to us. And so like most of the carbonates, calcium carbonate is going to be unable to dissolve in water. That would be our prediction for calcium carbonate. But what if we were part of those exceptions? Our final example, sodium carbonate, Na2CO3, falls under the carbonate rule on the right-hand side. Most carbonates are not able to dissolve in water. We're obviously not ammonium carbonate because we're sodium carbonate. But we do need to go to the periodic table and check if our cation falls under group 1. So we go open our periodic table, we find sodium, and we see that it is group 1, which means that this exception does apply to us. And since we are an exception, we're not going to stay on the right-hand side of the solubility rules with the rest of the carbonates. We would fall on the left-hand side, predicting that sodium carbonate will be able to dissolve in water. So that's how you use the ionic solubility rules found on page 6 of the reference tables to predict whether a particular ionic compound will be able to dissolve in water or not able to dissolve in water. Thank you very much.